Hello everybody, and welcome to today's webinar presentation, How to Fix the 5 Most Common AWS Infrastructure as Code Misconfigurations, brought to you by Bridgecrew. So I'd like to introduce you to our presenter, Taylor Smith. Taylor is a Senior Product Marketing Manager for Bridgecrew by Prisma Cloud. He helps customers integrate security into DevOps practice to secure the entire cloud-native stack. Previously, he held product marketing and strategy positions at Gremlin, Cisco, and NetApp. And with that, I will pass it over to Taylor.
Hey everyone, thanks for joining. I'm going to jump right in. So these are how to fix the 5 most common AWS IaC misconfigurations. And let me just hit play. All right, so if you're not familiar with infrastructure as code, I'm going to do a very quick high level overview. Essentially, what infrastructure as code did is it took all the different steps that you had to do to provision and manage and remove infrastructure and codified it. So instead of the 8 different clicks it would take to build out a virtual machine on AWS, you could do that in just a few lines of code. And you can see on the right, this is an example Terraform file. It's a lot more human readable, it's a lot easier to digest, and really critically, it's a lot easier to collaborate around. The problem with this is that what we found, a whole bunch of our researchers went through and scanned a whole bunch of open source Terraform files and CloudFormation files and found that a good chunk of them, 42% and 44%, are misconfigured. So you can't just take infrastructure as code off the shelf and assume it's safe to use. Now, I'm going to provide a few examples of this. So these are the top 5 that we identified and how to fix them. Now, the source of this data is we went through all the scans that Bridgecrew has done for Terraform and CloudFormation and looked at all the most common AWS misconfigurations that occurred across all of those, aggregated. Now, confession time. I didn't just take the top 5 as they stand. Starting with the lows, I totally ignored all the low severity misconfigurations. Here's an example. Ensure taggable resources are tagged. That's just not exciting. I'd rather talk about more exciting things. Also, we have a tool. If you want to automatically tag your resources, there is an open source tool called Your that will automatically tag your resources. So the next thing that I did with this top 5, if I just took the top 5, I'd have 2 networking issues that are very related. I have 1 secrets and then a whole list of IAM issues. So I merged those to basically have a combined list, so that way you have unique categories. So these are the top 5, not low, misconfigurations grouped by category. All right, with that, let's jump in. So the top 5 that we found come down to networking, where remote server access ports are open to the world. So this is port 22 or 3389 in the case of RDP. And secrets exposure, hard-coded AWS credentials specifically, included in Terraform files or CloudFormation files that were checked into code. And then there's IAM, overly permissive IAM roles. Then there's S3 with S3 buckets. It was encryption turned off or versioning turned off, which is the default, but you really should have both of those turned on. And then for EBS, it's unencrypted launch config. So if you are running auto scaling groups, this means that the EBS volume that's being used to provision those EBS volumes is unencrypted. Now, I'm gonna jump in. So I'm going to walk through each of these, the misconfiguration that they represent, and what it means to fix them. How do you fix them in both CloudFormation and in Terraform? Now, a quick logistics thing, please feel free to add questions at any time. I'll either address them as I go or at the end. So first, I'm going to do a quick showing of our open source offering, Checkoff. So we have here a Terraform template that's provisioning some EC2 instances with a security group and an S3 bucket and with some IAM credentials. And I have a very similar file for CloudFormation here. And I use the YAML rather than JSON version. So these two files do the exact same thing, just one does it in Terraform, one does it in CloudFormation. And if I do a quick scan of these, I'll show you what it looks like. So I'm going to do Checkoff, which is our free and open source tool to scan these. And let's start with the Terraform, and I'm going to do quiet. What this is going to do is it's just going to show me the misconfigurations. It's not going to show all the past checks. And, oh, sorry about that. I forgot. I added an additional double dash. All right. All right. So we have here all the different misconfigurations. So you can see I have my AWS access key. I have a high entropy key, which happens to be my secret key. And then I have some overly permissive IAM roles, etc. So I have all these different misconfigurations. Up here, I have a nice summary where I have passed 10 checks and failed 7, and then I've skipped some of the irrelevant checks. All right, the other thing I can do is to scan the CloudFormation one. Same thing. And you're gonna see we're gonna have those exact same misconfigurations show up here. All right, so you can see another high entropy string, data stored in EBS is not securely encrypted, etc. So we have all those different misconfigurations in both. All right, so that's what it looks like to have an insecure template. Now, the important thing here is to note is that this is fully deployable. So both of these code, even though they're misconfigured, I could do Terraform apply, or I could plug it into CloudFormation and deploy insecure infrastructure. The better solution would be to secure this infrastructure in code before we move to production. So let's take a look at what that would look like. All right, so remote access ports. If you're not familiar with SSH or RDP, this is basically where you take your machine and you get a secure tunnel to connect in and do administrative tasks on a server. So SSH is the most common for Linux, or RDP is common for Windows machines. And it basically opens up a terminal that you can do all your commands on that remote server. The bad thing is that if a bad actor gets a hold of that key, your access key, or your password, then they can get into your SSH instance. And so with defense in depth, what we want to do is we want to add a layer to block this. And so in security group, if we add a rule in our security groups to block based on IP address, then we can really limit the blast radius. We can really limit who can get in, even if they have access to the key. And so an example of that would be either your own home box. You just do an IP, get your own IP address and plug that into your SSH. So instead of SSH open to quad 4s, you just open it up to your IP address. Or it might be a bastion host. So this is just like a hop where you first remote into a remote server, like an EC2 instance, and then from there remote into the SSH into your server that you want to actually configure. And you limit the IP address to just the bastion host. All right, so let's take a look at what that would look like. So first, if I go into my SSH, my security group here, in the Terraform file, you can see I have port 22 open to the world. And so that's obviously not what I want to do. I'm going to take this address, IP address, it's not mine, so I don't recommend doing anything with it. But it's just a random IP address. I did a /32, it could be a block. If it's an internal, like a bastion host, then it could be a block of internal IP addresses, like a 10 dot. All right, and then same thing over here. I'm going to find that same port 22 and port 3389, and I'm going to close it off. So it's just the IP addresses I want. And that way, if a bad actor got a hold of my encryption keys, they couldn't do anything. My SSH key, they couldn't do anything. All right, the next one is when you have secrets hard-coded into your IaC template. And then you check them into a source code repository like GitHub or GitLab. All of a sudden, those secrets are now exposed to the world. And so your secrets, your AWS access keys, are used to give you API access. So you can do all the provisioning, spin up EC2 instances, spin up RDS instances, manage clusters. This is really the keys to the kingdom. It gives you the same access that you have, that your user has. And so if somebody has access to both the AWS access key and secret key, they can do all the things that you can do in AWS. And an example of this might be if a bad actor gets a hold of these keys, they might spin up a whole bunch of GPU instances to mine Monero cryptocurrency. And this may seem abstract or unlikely, but this has really happened. This is a very unfortunate story about somebody who actually had a typo in their git ignore. And so when they committed their code, it had their access key and secret key in their repo. And so just one small typo opened up a $6,000 bill overnight. Guy went to bed, checked in his code, and then woke up with a $6,000 bill. So what we want to do is, and I've commented these out on purpose because they don't, these are fake keys, and so it wouldn't work when I do like a Terraform apply. But what I want to do is I want to get rid of these. So you can, in the provider section of AWS, put these keys here. What you should do instead is either include them as environment variables or include them in another file that you use gitignore to completely ignore. All right, so I'm going to do the same thing over here. It's not as relevant in CloudFormation because you're using it CloudFormation from your account. So instead, it might be included if you have a host that's doing some actions on your behalf, like spinning up clusters on your behalf. So this might be like a CI/CD pipeline like Jenkins. All right, so I want to close that off. All right, so now I've gotten rid of those access keys and secret keys. Now, if you do expose your access keys and secret keys, I'm going to take a pause here, or any secret, the best approach is to disable and revoke those keys as soon as possible. And then look for any compromised services. So go through your CloudTrail logs, go through all your different logs of your different systems, make sure nothing nefarious is happening. And then clean up your history, because even though you've revoked those keys, you don't want them out and exposed. You don't want people kind of sniffing around your repos. And then monitor your supply chain, so look for anomalies and consistently look for that. And then add automation scanning for secrets like Checkoff, so you can find those secrets and block them before they're ever scanned in the future. And then make sure you add in automation to do all this for you. Add in sensitive variables either into a storage secrets manager like Vault or in gitignore, in a file that's ignored with gitignore, and make sure you scan before you commit anything. All right, the next one is overly permissive IAM roles. And this is a large category. So it's not just one thing, but it's opening up access to everything, or giving permissions to do whatever they want, free reign with any resource. So the specific one that we're going to correct here is access or unlimited access to do whatever you want to do. So unlimited actions. So the idea here is, if you have an IAM role, the person who's doing an action on behalf of for AWS, or on behalf of AWS, is given permissions through IAM. And IAM limits or allows what they're allowed to do in AWS. So if I'm trying to spin up an EC2 cluster for my web instance, I will assume the role of EC2 create, and have the ability to do actions of EC2 create, and then I'll be able to make CRUD calls to AWS to say spin up some instances. Now, the reason why you need to make sure this is limited is if a bad actor gets a hold of your permission, if you're of your keys, or somehow gets access to your UI, the AWS UI, then they will have all the same permissions you do. So similar to the last one, if they get access to your abilities and you're able to spin up GPU instances, then they're able to spin up GPU instances and start mining Monero. The whole idea here is if you limit to least privilege access, then even if the credentials are compromised, the bad actor can't do as much with them. So for example, there's a story of somebody who got access, a bad actor got access to the CI/CD credentials that could spin up EC2 instances in order to do a test environment. What they could have done, and then what they found is that people were spinning up a whole bunch, when they were compromised, a whole bunch of GPU instances were spun up. What they could do is limit the access to only be able to create normal instances and like T2s or whatever the minimum is that they needed, and don't allow them to do things like describe all their instances or get access to S3 buckets. That way, even if they get a hold of those credentials, there's defense in depth, they're blocked from doing much with them. All right, so let's take a look at what that would look like. So in Terraform, I'm going to go in here and I'm going to look for my IAM role. All right, so I have my IAM role here, and you can see the action I'm allowed is everything. And then similarly over here, in my IAM role, I have allowed the action to do everything for every resource. So this is obviously way over permissive, and we want to limit that down. So in the case of this, I just want this user to be able to describe EC2 instances. And so I'm going to limit this. In the case of my Terraform file, I'm just going to give them the ability to describe instances. All right. And then similarly over here in AWS and CloudFormation, slightly different syntax. I'm just going to give them the ability to describe instances. All right. So now my IAM role is locked down. They can't do nearly as much with it. Let's take a look at the next issue. All right. So the next issue that we found was the most common was having S3 buckets without encryption or versioning turned on. Now, this is one where I think everyone should be familiar with it. S3 buckets by default are not encrypted when they're stored, and they also don't have versioning turned on. Now, the encrypted turned on, that should be a no-brainer, turn that on. Versioning can cost more because you're basically storing multiple versions of the same file, so storage costs build up a little bit faster. However, it's very good policy to turn both on. And the idea here is if a bad actor steals it and it's unencrypted, steals data and it's unencrypted, they now have access to the file. If it's encrypted, then they won't have access to the file. They'll have to figure out a way to unencrypt it, which could take years. Same thing with versioning. Basically what this would do is if somebody accidentally deletes a file, then it's then it's gone and the file no longer exists. However, if a file is deleted and there's versioning, now you have old copies of that file. Or if the file's corrupted, let's say somehow somebody went in and encrypted it, then you wouldn't have access to that file. But if you have versioning, you could just look back one version and still have access to that file. And another good idea to do here, I'm not going to show this off, but it's a good idea to turn on MFA delete. So if somebody tries to go in and delete a file that they shouldn't, turning on MFA delete makes it so they have to have multi-factor authentication, which just gets rid of some of the phishing issues. All right, so let's take a look at what that looks like. So in Terraform, I'm going to look for my S3 bucket. So I have it here. And what I need to turn on is server-side encryption and versioning. So first thing I want to do, let's just turn on server-side encryption. Okay, so server-side encryption configuration, and let's just do rule. All right, and that's turning it on by default. And let's just set that to, you can do KMS, or in this case, I'm going to do AES 256. All right, so that's turning on encryption by default. Now we want to turn on versioning. So that's as simple as just saying versioning and then enabled equals true. All right, so I've got encryption turned on, AES 256, and I've got versioning turned on. All right, now I need to do the same thing over here. So I think my S3 bucket is right here. All right, so I'm in the properties section of my CloudFormation template. I'm gonna just turn on bucket encryption. And let's do server side. And we'll do server side encryption by default. There it is. And SSE will be AES 256. All right. So that's turned on encryption by default. And then I also want to turn on versioning. So let's do versioning. There it is, status enabled. All right. So now my S3 buckets have both been turned on. The encryption's been turned on and the versioning's been turned on. All right. And then the last and final misconfiguration is unencrypted launch configs. So the problem here is in a launch config is used by autoscaling groups to create EC2 instances. So for example, an autoscaling group basically says if there's a whole bunch of traffic, or in this case, CPU spikes or memory spikes, then it will scale out. So it will add another instance automatically. And it uses the launch configuration to basically just to configure those new instances they're spinning out. And if those volumes are not encrypted, then some bad actor could get a hold of those and figure out what's going on in the source code, and basically do some nefarious things. So the whole idea here is you want to encrypt those so that the encryption is basically secure from at rest and also in motion between the actual EBS volume and the autoscaling group once it's scaled out. All right, so let's take a look at what that looks like. What we want to do is under in the launch config, let me just search for this launch configuration. There it is. So what I want to do here is just set the root block volume device to encrypted, and that's it. That'll encrypt that launch config. All right, so similar thing over here. I've got my auto scaling group and I've got my launch configuration. Under properties, I'm just going to add here there it is. All right, and then block name, this can be whatever you want. I'll just do dev SDA1. And then we want to do EBS encrypted true. All right, so now I've gone through and I've added in encryption for these EBS volumes. So now what I'm going to do is I've made all those fixes. Let me just make sure I save those. I'm going to scan those same files and see what happens. You can see I've now passed all my different checks except for the ones that I skipped. And let's do the same thing with CloudFormation. And you can see the same thing. I've passed all those same checks except for the skip checks. And so now I've added in the fixes for all of these. Now, tools like Bridgecrew will help you do this a lot easier with our fix suggestions, but Checkoff, our open source tool, is a really good way to have that baseline check, and it also can block builds from being deployed if they're misconfigured. All right, so in a quick summary, lock down your admin access ports, so SSH and RDP. Make sure the IP addresses are limited. Don't include secrets in your IaC templates, and scan for those. Block them from ever being included in your repos. Grant least privilege access for IAM, so only give the IAM role exactly the actions and resource access that they need and nothing else. Encrypt and add versioning to your S3 buckets, and encrypt your launch configurations. So a quick reminder on what we added here. We changed the IP address for our port 22 and port 3389. We went through and we added encryption to our root block device. We added in encryption and versioning into our S3 bucket. And we locked down the actions that our IAM role could do. And we did that in both Terraform and CloudFormation. So thank you for watching. That was my presentation. If you have any questions, please let me know, include them in the chat. Also, if you want to try this out for yourself, Checkoff is free and open source. You can always go on there. You can also head over to bridgecrew.io. We have a Slack channel for called Codified Slack, Codified Security. That's where you can ask some more questions, reach out there, or you can try this out for yourself for free. The full Bridgecrew platform is available with 14-day trial at bridgecrew.io. Thanks so much. I'm just going to see if there are any questions here. All right, so one of the questions, what were the next misconfigurations identified? So I did actually, let me pull that up. So the ones that we saw after these top 5 were, let's see, public access turned on for S3 buckets. So people going through and saying that the public can access their S3 buckets. You obviously want to lock that down. And then logging turned off. And that logging turned off could have been grouped because it was logging turned off everywhere. It's logging turned off for EC2 instances, logging turned off for load balancers, etc. So the reason why you want logging turned on is you want that audit trail of all the bad things that have happened, but also for ops reasons. It's a good idea to turn on logging because it helps you triage and fix issues. All right, the next one. What's a good way to prevent these misconfigurations? So my recommendation is to use a tool like Checkoff in your CI/CD pipelines. Also, we have an extension for VS Code, so you can see as you type your infrastructure as code templates out, all the different misconfigurations, and make sure they're fixed, and then use a guardrail methodology. So in your CI/CD pipeline, block builds that have high severity or medium plus severity issues from ever being deployed or committed into your repos. And that way, at the source, things are blocked and secure from the beginning. Great. And then the last one that I've here, but please feel free to add more. What are some of the challenges in getting these fixed, and why aren't people fixing these issues themselves? So this is a great question. I think it really comes down to a few things. One, it's a lack of knowledge on both sides. So the developers are not security experts. They're experts in their field. So they might be front-end developers who really know how to write infrastructure as code to build out a web platform that they can write Node.js for, but they don't know the actual security of that. And then on the opposite side, security really knows security, but they don't necessarily know how to code. And so some security experts know Python, but infrastructure as code templates like Terraform might be a little foreign to them. So the developers aren't securing it because they don't necessarily know how to, and then they might forget things because, like, for example, us, we've thousands of policies. It's tough to remember all of them. And then the security team is not able, they might find all these issues, but they're not able to fix them. And so there's this disconnect between the two teams. And that's really where automation and DevSecOps, so bringing those two teams together so they're collaborating more from the beginning, but also adding in automation tools so feedback comes early to the developers as they're building out their infrastructure as code templates, really will get things fixed and grease the wheels to get things fixed a lot easier. And then people can fix them themselves. Great, so that was the last of the questions. Unless there are any more, I just want to say thank you again for everyone who showed up, and thank you for listening to my rant about misconfigs. I hope this will give you some knowledge about how you can fix some of these issues in your own infrastructure as code templates.
All right, and with that, DZone would like to thank Taylor for a great presentation. DZone would also like to thank Bridgecrew for providing the audience with a wonderful webinar. Lastly, thank you to everyone who attended today. We hope you learned something new that will help you in your developer career.